Good evening, students. Now let us discuss about alternating current or alternating voltage through a pure resistance or resistor. For discussing about the property of pure resistance, we are taking the support of the circuit diagram, vector diagram and waveform, two types. One is voltage and current, the other one is power. In both the cases, the time is important. In the circuit diagram, R will be representing the pure resistance which is subjected to an alternating EMF or alternating voltage which creates the current I, instantaneous current I, that is taken as I maximum sin theta. Applied instantaneous EMF is E maximum sin theta. Now you can see here, so in the vector diagram, voltage and current, they are in phase with each other. It means they are parallel to each other. Maybe magnitude of the voltage and current may be equal or may not be equal, doesn't matter. But they are parallel to each other and the angle subtended between them is 0 degree. So that is the special property of the pure resistance. You can represent both the vector diagram or the vectors on the same line because the angle is 0 degree. The same can be observed in the waveform also. Starting point of the voltage and current is same. They are moving to the maximum value at the same time and coming back to 0 at 180 degree at the same time. I mean to say they are equally moving and there is no difference in between the two vectors. That represents that voltage and current, they are in phase with each other. And coming to the power which has been dissipated across the pure resistance here, you know that power is the product of EMF and current. Assuming here the firm line is representing the EMF, dotted line is the current, and product of both, that is giving the peak power or the maximum power. There is no loss here. It means the power dissipated in case of the pure resistance is very high, and that power is called as the active power, which I have mentioned here in serial number 8 in the properties. Active power is very high, whereas the reactive power will be 0. There is no reactive power in case of the pure resistance. So I think you have understood the multiple law of current pulse as well as the voltage pulse will give you the high power pulse, that is the active power. There is no reactive power here. So you can say that in case of the pure resistance, power neither be 0 nor be negative, but always positive and high. It means it dissipates the active power maximum so that the work done will be very high in case of the pure resistance. So now you can say here under the title here properties, voltage and current are in phase with each other, that you have seen already in the vector diagram as well as the phasor diagram. And the phase angle between the voltage and current is 0 degree. And the power factor always, which is cosine of the angle between the current and voltage, is unity. Why? Because cos 0 is 1, you know mathematically, and it dissipates or produces the active power, which will be always high. There is no reactive power here, that's why it is shown as 0. So further we can discuss about the pure resistance, again clubbing with the inductance, capacitance in the next lesson, but about the AC through pure resistance, you must understand this logic. Thank you.